Hello, Algebra 1 students, and welcome to Lesson 22, which is about volume of pyramids, cones, and spheres. This is another lesson in our series about surface area and volume of three-dimensional solids. And today we're going to be introducing some new objects called pyramids, cones, and spheres. And we're going to study the formula that we use to calculate the volume of these shapes. Now, just recall, we already have one formula down in our volume tool belt, I guess I could say. Volume equals area of the base times height. Now, before we start the lesson, I just want to remind you, this is a correct volume formula, but only for prisms and cylinders. So today, we're going to deal with a different species of geometric solid, pyramids, cones, and spheres. So, we're not going to be using this formula today, so I'm just reminding you. This guy is for prisms and cylinders. So today there's going to be a lot of new formulae to write down. So let's get started. First of all, a pyramid is one of these new terms that we're learning. It's just a polyhedron. Remember, a polyhedron is a three-dimensional solid made up of only flat faces. A pyramid is an example of a polyhedron with one polygonal base. So one base, that is a polygon. In this case, this is a square pyramid because the base is a square. And the thing about a pyramid is that it starts from the base and then everything in the base kind of contracts up to a single point at the top, which we call a vertex or an apex. The distance from the base to the apex of a pyramid is called the altitude, or the height. The length from the corner of the base to the vertex is called the lateral edge. And the length from the center of the sides of one of the base to the vertex is called the slant height. A right pyramid is a pyramid with an axis perpendicular to its base. Now, this altitude right here, that is also the axis of the pyramid. Axis, altitude, and height are terms for the same thing, so I'll be using them interchangeably. Here's some examples of pyramids. You could have a triangular pyramid, square pyramid, pentagonal pyramid, or hexagonal pyramid. And the names of each of these comes from what is the base of that pyramid. Here we have a triangular pyramid with a triangle at the bottom, square pyramid with a square at the bottom, pentagonal pyramid with a pentagon at the bottom, and a hexagonal pyramid with a hexagon at the bottom. A regular pyramid is an example of a right pyramid whose base is a regular polygon. So, remember, we have weird examples of polygons and then we have the really regular examples of polygons, like squares or perfect hexagons in this case. In a regular pyramid, the altitude and the slant height form a right triangle. Remember, the slant height is the distance from the center of one of the edges of the base all the way to the vertex. The slant height and the altitude in any pyramid make a right triangle. Now that's an important observation that we'll just save for later on. The volume of a pyramid has a different formula from what we have been doing before. The volume of a pyramid is given by 1/3 times the area of the base times the height. So remember how we had, with prisms it was just area of the base times the height? If you're trying to find the volume of a pyramid, then you will multiply by 1/3 and then do area of the base times the height. So I would say this is pretty similar to that old area formula plus this factor of 1/3. And that's a kind of cool observation because what that means is that the volume of a pyramid is 1/3 the volume of a prism that kind of fits around the pyramid with the same height. So, an example. Let's find the volume of a right rectangular pyramid with dimensions 6 by 8. So the base of the pyramid is a rectangle that is 6 feet by 8 feet. The height of the pyramid is 11 feet. So let's use that formula. The volume is 1/3 times the area of the base times the height. The base is a rectangle with an area of 6 times 8, so 48. And the height is 11 feet, so we're trying to evaluate 1/3 times 48 times 11. We cancel that out, we get 16. 16 goes into 48 3 times. And 16 times 11 is 176. So our answer is 176 feet cubed. Oops, there we go. Another example, or another definition. A cone is like a pyramid, except its base is a closed curve instead of a polygon. So pyramid, your base is a polygon, but a cone is what happens when you try to make a pyramid with a closed curve as a base. Simplest example of a closed curve is a circle. The lateral surface of a cone is the curved surface between the base and the apex. So this curved surface. The axis of a cone is the segment joining the apex to the center of the base. So in this case, this line is the axis. The altitude is the perpendicular segment from the vertex to the plane of the base. So in this case, since this is a right cone, the altitude and the axis are the same. The length of the altitude is the height of the cone, right? So that's basically saying the altitude and the height are the same measurement. Now the height of a cone is the shortest distance between the apex and the base. So the shortest distance from the apex to the base here is just the distance from the center of the base all the way to the apex. Now most of the time, if you have a right cone, then the axis, the altitude, and the height will actually be the same measurement. The one thing that's different is the slant height, which is the distance from the apex of the cone to any point on the edge. Any point on the edge of the base. The distance from the apex to any point of the circle that forms the base is called the slant height, like I said. In a right circular cone, the altitude and the slant height actually make a right triangle. So this is another one of those right triangles, like we had with the pyramid. So the volume of a cone has a formula as well. It is 1/3 area of the base times the height of the cone. If you look back at our other formula, you'll notice the volume of a pyramid, 1/3 area of the base times the height, is the same formula for the volume of a cone, 1/3 area of the base times the height. So in this second example, let's find the volume of a cone. The radius of the base is 7 inches, and the height of the cone is 6 inches. I like to draw a picture. Let's draw a cone, not a very fancy cone. The radius of the base is 7 inches, and the height of the cone is 6 inches. Okay, so this drawing is not to scale. I would think probably the cone looks something like that. So we're trying to find the volume of a cone, which is just as simple as doing 1/3 area of the base times the height. Now the area of the base of this cone is the area of a circle. The radius of that circle is 7 inches. So I can use pi r squared to write the area of the base as 49 pi. The height of the cone is 6 inches, so we replace that with 6. And now we have to solve. And so now we get the volume is 98 pi inches cubed. The units are inches cubed because, well, we're in 3 dimensions. We're measuring volume, so we're using units of volume here. Let's move on to another example of a new kind of shape. Not a prism, not a cylinder, not a pyramid, not a cone. This is a sphere. A sphere is a set of points in 3-dimensional space that have the same distance to the center. So kind of a 3-dimensional circle, right? The idea with a sphere is that you start with a point, then you choose a radius, and the sphere is entirely determined by that radius. Now this is the same thing as a circle, where a circle is entirely determined by its center point and its radius. To find the volume of a sphere, we have a special formula that doesn't look like any of the other formulas we've worked with before. Remember how when we introduced area of a circle, it was like, we've got this weird formula, pi r squared, that you basically just trust and say, okay, let's use pi r squared. So in this case, the volume of a sphere is given by 4/3 pi r cubed for reasons that are very difficult to outline without a major understanding of calculus. Now, if that sounds exciting to you and you're interested in the challenge, then stick around, take calculus. It'll only be a few years till you get there. The volume of a sphere is an interesting observation. The volume of a sphere is exactly 2/3 of the volume of a cylinder that fits around it. So there's this kind of interesting connection between cylinders and spheres and cones and cylinders, where this sphere actually takes up exactly 2/3 of the volume. Even though it's all curvy and weird, it still takes up this exact ratio of the volume of a cylinder of the same size. So in an example, you might be asked to find the volume of a sphere with a radius of 6 inches. Well, basically, once you know that the radius is 6 inches, you know everything there is to know about the sphere. Remember that we're using the formula 4/3 pi r cubed. Cubed in this case, not squared. So we haven't seen a pi r cubed yet. Now take that radius and replace it with 6 inches. It told us the radius was 6 inches, so we have to take 6 and cube it. Now what is 6 cubed? Well, 6 squared is 36, so we multiply 36 by 6. So that would be 216. 36 times 6, yeah, okay, 216. And then we will cancel this guy out. So 216 is divisible by 3, luckily, right? So that is 72. 216 over 3 is 72. Right, double check that. Yeah, that's true. And then we do 4 times pi times 72. And 4 times 72, well, that's 4 times 70, 280. Then we have to add 4 times 2, which is 8. So 288 pi inches cubed is our final answer. So I would write that like that. V equals 288 pi inches cubed. Not too bad, right? Once you know the formula, you plug in that number and boom, your answer comes out. So here's a summary. This is what I would like for you guys to have in your notes. Anything that's boxed in this angry red box should be in your notes. The volume of a pyramid is 1/3 area of the base times height. The volume of a cone is 1/3 area of the base times height. Notice those two are actually the same thing. The volume of a sphere is 4/3 pi r cubed. As long as you are leaving this lesson understanding these formulas or memorizing these formulas, then we should be pretty good. So anyway, please let me know if you have any questions. And happy Tuesday, and I will see you guys next time.